Welcome. In this video, we're going to look at an example of a related rate question. Here, a woman walks away from a flagpole at the rate of 4 feet per second. If the flagpole is 25 feet tall, at what rate is she walking away from the top of the flagpole when she is 15 feet from its base? So what I've done is drawn a picture to kind of give the scenario. And we need to put some variables in here. We are assuming that it's on level ground and that the flagpole is set perpendicular to the ground. And so that gives us the right triangle. The flagpole is 25 feet tall. So I've done the vertical part of our right triangle as 25 feet. And so the ground is the horizontal component of the right triangle. And she is walking away from the flagpole. So her distance from the flagpole, we're going to call x. And we're measuring this distance that she's away from the ground to the top of the flagpole. So from her feet up is the distance that we're talking about. Now, we also need a variable for the hypotenuse. We'll just call this s. So when we look at the information, it's important with the related rates to identify the information that's given and identify the information that you want to find, and also notice any sort of geometrical or other sorts of formulas that might help you. So it says that she is walking away from the flagpole at the rate of 4 feet per second. And so since that's her distance from the flagpole, and its a rate is the change of distance with respect to the change in time, we have that dx dt, the change in her x distance away from the flagpole with respect to the change in time, is that 4 feet per second. Now we have that the flagpole is 25 feet tall. And it says, at what rate is she walking away from the top of the flagpole? So it's asking me for the rate that she's walking away from the top of the flagpole. So that is from the top of the flagpole down to her feet. So that is the rate of change of s. So ds dt is what we are looking for. And we're looking for that when she is 15 feet from the base. So that's when x is equal to 15 feet. So now what geometrical formula can we use here? Well, it's a right triangle. And when we are talking about the relationships between the sides of the right triangle, that's Pythagorean theorem. So we have legs squared, 25 squared, plus x squared, the other leg squared, is equal to the hypotenuse, s squared. Now 25 squared is 625, plus x squared is equal to s squared. And we can go through and find our derivative now with implicit differentiation, and we are looking at it where x and s are both dependent variables on the independent variable of time t, and we know that because of the way our derivatives are set up. The dx dt, x is dependent on t, and the ds dt, s is dependent on t. So the derivative of the constant term 625 is 0, plus the derivative of x squared is 2x for the derivative rule, but x is dependent on t, so I have to multiply by dx dt by the chain rule, is equal to the derivative of s squared is 2s, but s is dependent on t, so by the chain rule I have to multiply by ds dt. Now when we look at what we are given and what we want to know, I have a value for x, it's 15. I have a value for dx dt, that's that 4 feet per second. I don't yet have a value that I've calculated for s, and I want to know ds dt. So at first glance it looks like maybe we don't have enough information because we don't have our s. But we have to remember that when x is 15, we have that right triangle where I have a 25-foot vertical on my right triangle. When x is 15, the horizontal leg of the right triangle is 15, so I can use the Pythagorean theorem, 25 squared plus 15 squared is equal to s squared, to find the value of s at that time. So I have 625 plus 225 is equal to s squared. That gives me 850 is equal to s squared. So s is equal to the square root of 850 when x is 15 and your flagpole stays at its 25 feet, which as a simplified radical, s is equal to 5 times the square root of 34. So now we have all but one thing missing, so we can plug in our values and solve for that. So I have 2 times, take out the x and put in my 15 feet, times take out the dx dt and put in 4 feet per second, is equal to 2 times s, take out the s and put in 5 square roots of 34 feet, and then times that ds dt. So simplifying the left-hand side, I have 2 times my 15 times feet times my 4. That gives me a value of 120 square feet per second. Just bringing our units along, and we will see how they work out as we go through the rest of the calculation. And then I have 2 times 5 times the square root of 34 feet times ds dt. So that's 10 times the square root of 34 feet times ds dt. And then solving for ds dt, we want to divide both sides by the 10 times the square root of 34 feet. So I have 1 over 10 times the square root of 34 feet times my 120 feet squared over seconds is equal to ds dt, and my feet unit in the denominator will remove one of those in the numerator, and then simplifying the values numerically, I have 12 over the square root of 34 feet per second is what we get for our ds dt. And so the units work out to be what they should be because it's in the change in distance with respect to the change in time. Now there's a couple other things we can do with this exact answer. First thing we can do is rationalize, and if you rationalize and simplify it, you get ds dt is equal to 6 times the square root of 34 over 17. And if you approximate that, it's approximately 2.058 feet per second. And that is the rate that she is walking away from the top of the flagpole when she is 15 feet from its base.